Welcome back to our video course on AI. In this module, we are diving deep into the data that fuels AI. We will cover the entire life cycle, from collection and cleaning to labeling, and explore why bias and privacy are such critical concerns. In our last video, we explored how models learn from data. Now, we examine that data itself. Over the next 5 parts, we will see where it comes from, how we clean and label it, and how bias and privacy issues can arise. Let's start with part 1, where data comes from. Before any model can learn, data must be gathered. Let's look at the actual ways this happens. There are 5 main ways data is collected. We have direct input, passive collection, public and scraped data, purchased or licensed datasets, and even synthetic data. We will unpack each of these. Direct input occurs when you provide data willingly, such as through forms, surveys, or signups. While this data is generally accurate and consensual, it is limited in scale and prone to self-report bias, as people may not always be honest. Passive collection happens without your direct action, often gathering clickstream data, location history, or sensor readings from your devices in the background. This allows for massive, large-scale behavioral datasets that direct input could never reach. Public and scraped data comes from sources like Wikipedia, government datasets, or public social media posts. Scraping is the automated process of gathering this data at scale. The legal and ethical standards here are still evolving. Companies also purchase or license existing datasets from brokers. For scenarios where real data is scarce or too expensive, synthetic data, which is artificially generated to mimic real patterns, is an increasingly powerful alternative. All this collection has a real cost, including infrastructure, storage, and legal compliance. As we noted in Module 5, acquiring high-quality labeled data is often the most challenging and expensive part of an AI project. Moving to Part 2, cleaning and preprocessing. Because raw data is almost always messy, we must perform the essential, unglamorous work required to make it usable for a model. Raw data is typically filled with problems like missing values, duplicates, and inconsistent formatting. Data professionals spend the majority of their project time on cleaning, which is far more extensive than the time spent on the actual modeling. A typical cleaning checklist includes addressing missing values, removing duplicate entries, standardizing formats like dates and units, and identifying outliers or errors to ensure accuracy. Here is a worked example. On the left, you see the raw data with duplicates, missing fields, and errors. On the right, after one cleaning pass, we have removed invalid records, filled in blanks, and standardized the entries. Remember the mantra, garbage in, garbage out. No matter how sophisticated an algorithm is, it cannot fully compensate for poor quality data. The training math relies on trustworthy data. Otherwise, it will simply optimize toward the wrong answer. Finally, we use normalization to put data on the same scale. If features like age and income have vastly different ranges, models can be unfairly skewed. Normalization scales them so the model weighs them by importance, not just raw size. Moving on to Part 3 of our video, let's explore data labeling. This is the process of teaching the teacher, where we create the ground truth or correct answers that allow supervised learning models to function effectively. Who labels this data? There are 3 main sources, often used in combination. We rely on in-house experts, such as radiologists analyzing scans, crowdsourced workers on paid platforms, and users themselves, who naturally tag photos or mark spam. Labeling is challenging, because human judgment isn't always uniform. Labelers can genuinely disagree on ambiguous examples. To manage this, companies often use multiple people to label the same item, using consensus or voting to ensure reliability. Consider the ambiguity in classifying something as a chair. Does a beanbag count? What about a stool or a built-in wall bench? Because reasonable people can disagree, clear and detailed labeling guidelines are essential for consistency. At the frontier of AI, we use human feedback to refine large language models like ChatGPT and Claude. People rank or rate different responses, helping the model learn preferences, a process often called reinforcement learning from human feedback, or RLHF. In Part 4, we address a critical topic, bias in data. This occurs when data systematically misrepresents reality, which can have profound consequences that extend well beyond the numbers themselves. Bias happens when data over or underrepresents certain groups or outcomes, skewing what a model learns. Crucially, this is rarely intentional. It is usually an unintended byproduct of how that specific data was collected. There are 4 primary sources of bias. Sampling bias means the data doesn't represent the full population. Historical bias reflects past inequalities. Labeling bias carries human assumptions into the data, and measurement bias occurs when the method itself favors certain groups. In one well-known case study, researchers found that several commercial facial recognition systems had higher error rates for darker-skinned women. The root cause was that training datasets underrepresented these groups, so the model had not seen enough examples to learn accurately. Similarly, a major tech company once scrapped an internal resume screening tool after it was found to penalize resumes containing the word women's. The model had simply learned to reproduce the historical male-dominated patterns in the training data. Bias is difficult to eliminate completely. Often it remains invisible until tested against the right population. The realistic goal isn't achieving a perfectly unbiased dataset, but rather maintaining ongoing testing and a real willingness to correct course when issues arise. Finally, Part 5 covers privacy, ethics, and responsible data usage. As we collect data about real people, we must consider the rights and responsibilities that come with that information. Personally identifiable information, or PII, includes data that can identify an individual, such as names, emails, phone numbers, or biometric data. Handling this information responsibly, knowing what you have and protecting it, is a core requirement of ethical data collection. Techniques like anonymization help protect privacy by removing identifiers or adding statistical noise. However, true anonymization is harder than it sounds, as datasets can sometimes be re-identified by cross-referencing them with other publicly available information. Today, modern regulations like the GDPR grant individuals legal rights over their own data, including the right to access or delete it. Because these rules and the legal landscape continue to evolve, compliance remains a vital responsibility for any data-driven project. Now we reach the question of data governance. Organizations must constantly address who is responsible for data quality, who has access, how long data is stored, and when it should be deleted. Data governance is simply the framework of policies and processes that answer these critical questions. Let's recap the full data pipeline. First, we collect the raw data. Second, we clean it. Third, we label it for the model. Fourth, we check for potential bias. Fifth, we ensure privacy and security. Only after these critical steps are finished do we actually begin training the model. It is time to bust some common myths. First, more data does not always mean a better model. Quality and representativeness matter most. Second, just removing names doesn't guarantee anonymity, as other details can lead to re-identification. And third, bias often comes from unexamined defaults, not bad intentions. Now, here is a chance to check your understanding. Consider these 4 questions. What does garbage in, garbage out mean? Can you name 2 of the 4 types of bias? What does PII stand for? And why is true anonymization challenging? Pause the video to think about these. Let's review those answers. Garbage in, garbage out means poor input yields poor predictions. The 4 types of bias are sampling, historical, labeling, and measurement. PII is personally identifiable information. Finally, anonymization is hard because data can often be re-identified through cross-referencing. This vocabulary reference provides a summary of the core terms we covered in this module, from scraping and synthetic data to normalization and data governance. Feel free to pause and take a screenshot of this list for your future reference. Here are our key takeaways. Data comes from 5 main sources, and cleaning it is often the most time-consuming part of the job. Labeling relies on human judgment. Bias can emerge in several ways, and protecting privacy and PII is a non-negotiable responsibility in modern data work. Coming up next is Module 8, Python and your first lines of code. This is where we get truly hands-on. You will set up your own coding environment and begin writing the same types of code that working data scientists use every day. Congratulations! You now understand the fuel that drives AI. You have explored the entire data journey and its ethical challenges. I look forward to seeing you in Module 8, where we will start writing your first lines of Python code.